A very good morning, good afternoon, good evening, dear children. It is module number 3 under chemistry, where we are going to deal with shells, subshells, valency, and reactivity. How are the shells and subshells in an atom arranged? How are the electrons arranged in these shells and subshells? How does it control or limit the valency of an atom? And how is the valency of an atom related to its reactivity? It is just the basics. Let us start with a revision of the song which we had learned for learning the names and symbols of the first 30 more elements. Hi, hello, lively Ben. Buy a car now, okay? Fast and new, navigable, magical. All the single people sing, clap, and argue. Cool cat scratched, tiny worms crawled, man feared cobra, nice cute zebra. So, let us move on to the shells and subshells in an atom. So, learning about the shells and orbitals in an atom, we have already learned the atomic number of elements 1 to 30 with their symbols. You know that the electrons are arranged around the nucleus. We have also learned that the nucleus contains the proton and the neutron, and the electrons are arranged in shells around it. The shells or orbitals are those pathways in which the electrons in an atom move around the nucleus. They are also called as energy level. Now remember that the innermost shell will have the lowest energy and the outermost will have the highest energy. The innermost shell in any atom is K shell, and it can accommodate 2 electrons to the maximum. You can see it in the diagram. The nucleus with a proton and a neutron, and the K shell having 2 electrons. Then the energy level goes like this. After the K shell comes the L shell, then will be the M shell, and then the N shell, and so on. The maximum number of electron which can be accommodated in any shell can be calculated by the formula 2n squared. So K shell is shell number 1. So 2 into 1 squared will be 2. So that is why K can accommodate only 2 electrons. L shell is shell number 2. So 2n squared for L shell will be 2 into 2 squared, that will be equal to 8. So L shell can accommodate a maximum of 8 electrons. M shell is shell number 3. So 2n squared for M shell will be 2 into 3 squared, which will be equal to 18. So electrons in an atom always try to remain in the minimum energy level. So in any atom, the K shell gets filled first, then L shell, and so on. It is really interesting to note that every shell in an atom is made up of subshells. There are only 4 types of subshells in any atom: S, P, D, and F. Now, the shell K has got only one subshell, and that is S subshell. The shell L has got 2 subshells, subshell S and subshell P. Shell M has 3 subshells, subshell S, subshell P, and subshell D. Shell N has 4 subshells, subshell S, subshell P, subshell D, and subshell F. The S subshell can accommodate 2 electrons. The P subshell can accommodate 6 electrons. D subshell can accommodate 10 electrons, and F subshell can accommodate 14 electrons. So that is how we arrived at that 2n squared formula. As K has only S subshell, it can accommodate only 2 electrons. As L has got an S and a P, 2 plus 6, that becomes 8. M has got an S, P and D, that is 2 plus 6 plus 10, that is 18. N has got an S, P, D and F, so that is 2 plus 6 plus 10 plus 14. So that is how we arrive at the maximum capacity of any shell. Aufbau principle tells us how the electrons are getting filled in an atom from the lowest available energy level going towards higher energy level. Though this principle is not exactly required, it is to be understood for you to understand the atomic structure. The suborbitals are not filled strictly according to K shell, L shell, M shell and N shell. You can see the energy level by the arrow shown here. Lowest energy is the S shell in K. Next lowest energy is S shell in L. Then third lowest energy level is P of L. Then comes S of M. Then comes P of M, then comes S of N, then comes D of M, and so on. You just follow the red arrow which is given in this, then you will know which orbital will get filled first. So let us revise some of the basic definitions like valence shell, valence electron and valency. The outermost shell of an atom is called valence shell. The number of electrons present in the outermost shell of any atom is called the valence electrons. The combining capacity of an atom is called valency. See, normally electrons are lost, gained or shared. So whenever an atom combines or reacts with another atom, they either lose electrons, gain electrons or share electrons. This determines the combining capacity or valency. If an atom loses an electron, it will have an electron less than proton. So it becomes positive ions. If an atom gains electron during reaction, it will have an electron more than the protons. So it becomes negative ions. You know that atom is basically electrically neutral, having equal number of electron and proton. So loss or gain of electron will change the charge of the atom. And if it gets charged, we call it as ions. When there is a transfer of electron from one atom to another atom, the compound formed is ionic. If an atom share electrons, then it does not form ions. The electrons are basically shared, so they don't become charged. And the compound formed will be called as covalent compound. Now, as we have basically understood what is a shell and what is a subshell in an atom, let us take some examples and understand that. Let us take the group 1 elements, hydrogen, lithium, sodium and potassium. Now, these elements are represented here in the form of a table, and the number of electron, the electronic configuration, the valence shell and number of valence electrons along with the valence is shown there. You can notice that hydrogen has got one electron, so it is in 1s orbital. Valence shell is K, number of valence electron is 1 and valence is 1. Similarly, if you go to lithium, 3 electrons, arrangement is 2 1, shell is L and number of valence electron is 1. So if you go through the table, you will understand that all of them have one valence electron and their valency is 1. Now, if you look at potassium, you will be wondering about it. 19 electrons are there. 2 are arranged in K shell, then 8 is arranged in L shell, then 8 is arranged in M shell. Then why does the last electron go to N shell? M shell has a capacity of 18. So why does it go to N shell? This may be a doubt which may be coming in your mind. So in order to clarify it, there is one more concept which you have to basically understand. As explained to you earlier about the energy level and the filling of electrons as per Aufbau principle in the subshells, the electrons are not strictly arranged according to the shells. It is arranged strictly according to the energy level of the subshells. So according to that, first S shell of the K shell, then S of L, then P of L, follow that red dotted line, then S of M, after that P of M, then it is not D of M, it comes to S of N because S of N has got a lower energy level than D of M. So S of N followed by D of M and so on. As we have learnt the electronic configuration of group 1 elements, let us get into their properties. They are called as alkali metals. They have a S subshell as the outermost or the valence shell. They have only one electron in this valence shell, so alkali metals are all encountered or we meet them as anions. The alkali metals in their compounds generally lose electrons during reactions and form monopositive ions. They are mostly soft and shiny and highly reactive metals. See, hydrogen is not similar to this. We will deal with it in the next slide. All the alkali metals are highly reactive and easily react with air to get oxidized. So, most of them are kept under mineral oil or kerosene. All known alkali metals show increasing atomic radii. Obviously, the shells keep on adding, so the atomic radii goes up. It shows increasing reactivity and decreasing electronegativity. And they show decreasing melting and boiling points because the control of the outermost electron becomes less and less as we go down. When we discussed alkali metals, we did not include hydrogen in that. So let us see what is the special status of hydrogen. Hydrogen is a non-metal, doesn't behave like a metal, and it is placed above the group only because it has an NS1 electron configuration like the alkali metal. That is, the outermost shell is having one electron. However, it varies greatly from alkali metal in behavior because it loses electrons very reluctantly and doesn't do so easily like the alkali metal. It is the only electron it is having and it will not lose it. It normally forms bonds by sharing electrons. So, it is difficult to classify hydrogen as a metal or a non-metal. While hydrogen is typically gas on Earth, it can be artificially compressed and cooled to become a liquid or a solid. Even in these states, hydrogen remains a non-metal. Its atom holds on to the electron tightly, so hydrogen conducts heat and electricity poorly. So let us now go to group 2 elements, beryllium, magnesium, calcium and so on. They are called as alkaline earth metals. These alkaline earth metals have 2 electrons in their valence shell. So, they form doubly charged positive ions. As they lose electrons very readily, they form cation with a charge of +2 and their oxidation state is also called as +2. They are all shiny, silvery white, somewhat reactive metals and they react vigorously when heated with oxygen and get tarnished when kept in air. The atomic radii increases as you go down the group. This is the same for all groups. The elements become less electronegative. As the metal atom gets bigger, valence electrons are away from the metal nucleus and so is less strongly attracted towards it. The melting point also falls and the reactivity of group 2 elements obviously increases down the group as they are readily able to lose the electron because of the distance of the valence electron from the nucleus. So let us move to group 13 elements, which consist of boron, aluminium, gallium and so on. The general electronic configuration for this group is Ns2 Np1, 3 valence electrons. And so it exhibits an oxidation state of +3 and +1. But having said that, they find it easier to form covalent compounds than ionic compounds. Smaller the cation, more is the covalence as per Fejan's rule. They have a very high ionization enthalpy, which makes them forming ionic compounds very, very difficult. They have relatively higher electronegativity too. Losing all the 3 electrons is not easy. All the elements of group 13 react with oxygen at a high temperature to form trioxides, normally with the formula M2O3. All elements of group 13 except boron reacts both with non-oxidizing and oxidizing acids liberating hydrogen gas. The atomic radii of group 13 elements are lesser than their corresponding group 2 elements. This is because the effective nuclear charge increases, which makes the size of the atom smaller. The electronegativity first decreases from boron to aluminium and then increases from aluminium to thallium. The special behavior of boron is discussed here. Boron behaves differently from the rest of the elements in group 13 because of the following reason. One is it has got a very small size compared to the others, and so it has got a very high ionization enthalpy. It has also got high electronegativity because of its small size again and due to the absence of d orbital in the valence shell. So, it does not react easily. It doesn't react with non-oxidizing acids like HCl, but at a very high temperature, it reacts with strong oxidizing acids like a mixture of hot concentrated sulfuric acid and nitric acid to give boric acid. Boron resists the action of alkalis as well, like sodium hydroxide and potassium hydroxide, up to the temperature of 773 K, above which they form borates. Only boron combines with metals to form borides. Now coming to group 14, it consists of carbon, silicon, germanium, tin, lead and so on. These group 14 elements, they have a general electronic configuration of Ns2, Np2. So 4 valence electrons. The general oxidation state exhibited by this group are +4 and +2. That is, losing on all the 4 electrons or 2 electrons. The increase in the radii from carbon to silicon is considerable, after which the increase in radii is less. Down the group, the metallic character increases. Obviously, the number of shells go up and so the losing of electrons become easy. Carbon and silicon are non-metals. If you come to germanium, it is a metalloid. And tin and lead are soft metals with low melting points. They form covalent compounds in which all the 4 electrons play an active role. Most of the group 14 elements possess this property. All the elements of group 14 form hydrides and they form oxides of the type MO or MO2. They form tetrahalides of the form MX4. So let us come to the special property of carbon. Carbon exhibits different behavior from the rest of the group due to its small size, its high electronegativity, its high ionization enthalpy, and the absence of d orbital in the valence shell. The melting point of carbon is extremely high due to all these reasons like small size, high electronegativity and so on. In chemistry, catenation, the term means the bonding of atoms of the same element into a series called chain. The chain can be in ring shape also, which may be open at its end and are not bonded to each other, or the chain can be closed into a proper ring. Now, catenation occurs very readily with carbon, which forms covalent bond with other carbon atoms to form long chains and structures. Carbon is most well known for its property of catenation, which forms the basis of organic chemistry, essentially being the study of catenated carbon structure. This organic chemistry has got aliphatic and aromatic carbon compounds, where aliphatic are long chained ones and aromatic are ringed structures of carbon compounds. Arriving at the group 15 elements, these elements are basically nitrogen, phosphorus, arsenic and so on. These elements are called as nitrogen family elements. The non-metallic property, which starts with nitrogen, goes to metallic property as you go down. For example, nitrogen is a gas and non-metal. But as you move down the group, we encounter metalloids and then at the bottom you get bismuth, which is a metal. The configuration in the valence shell of this element is Ns2, Np3, 5 electrons in the outermost shell. The atomic radii increases as we go down the group. The electronegativity decreases down the group. Boiling point increases down the group. The common oxidation states of these elements are -3, +3 and +5. Except nitrogen, all the other elements in this group, they have allotropes. They exhibit different physical variations. Arriving at group 16 elements, it consists of oxygen, sulfur, selenium and so on. These members are addressed as members of oxygen family, and it is also called as chalcogen families because they are ore forming. Their valence shell has a configuration of Ns2 Np4, that is 6 valence electrons. The metallic property increases from oxygen when we move towards the last member, polonium. The atomic radii and melting point increase down the group. Ionization energy decreases down the group. The most common oxidation state in which these members are found is -2, and sulfur can also exist at +4 and +6 states. Let us now move to group 17 elements. They are fluorine, chlorine, bromine, iodine and so on. These group 17 elements are highly reactive non-metals. They have 7 electrons outside, and so they are very reactive, gaining electrons. They are commonly called as halogens. They have an outermost shell configuration of Ns2 Np5. The members of halogen family exhibit -1 oxidation state. Apart from this, elements such as chlorine, bromine and iodine also show +1, +3, +5 and +7 state. They react with metals and non-metals to form halides. Please note, they react with metals as well as non-metals. They are that reactive. They have the smallest ionic radii in their periods. Take their period. That is, if you compare fluorine with lithium and beryllium, boron, carbon, nitrogen and oxygen, then fluorine has the smallest ionic radii. They have high oxidizing properties and they have a very high ionization enthalpy. So we reach group 18 elements. These group 18 elements include helium, neon, argon, krypton and so on. They are also called noble gases because of their inert structure. Neon has got 2 electrons and the others have 8 electrons in the outermost shell. So their octet is complete and so they are all inactive. They have low atomic radii and high ionization enthalpy. They are gases at room temperature. They are non-reactive. Because of this property, they are used in a number of equipment. As helium is lighter than air, it is used in balloons and airships. Argon is used in light bulbs. Neon is used in advertising signs. Krypton is used in laser eye surgery and so on. So we come to the end of this particular module. Let us get to the question answer section. So here are some questions which will help you to remember the most important points you learned here. Name the element which is having an atomic number 7 and state its symbol. So atomic number 7 belongs to group 15. Symbol will be N because the element is nitrogen. To which group does it belong to? Obviously it belongs to 15. Now diagrammatically represent its atomic structure with its electronic configuration. So you will show a nucleus with the protons and neutrons, and as there are 7 electrons, it will be divided as 2, 5, 2 electrons in the K shell and 5 electrons in the L shell. Name one physical property of this element which distinguishes it from the other elements of the same group. Only nitrogen in this particular group is gas. All the other elements are not gas. They are solids. Mention one similarity between this element of atomic number 7 and 8. So 7 is nitrogen and the one with atomic number 8 is oxygen. Both of them have the similarity of being gases. Name 2 groups having non-metal, metalloid and metal in the same group. If you take group 14, carbon is a non-metal, germanium is a metalloid, and tin and lead becomes metals. Similarly, if you take group 15, nitrogen is a non-metal, arsenic is a metalloid, and bismuth becomes a metal. Name one characteristic each to debate that hydrogen is neither a metal nor a non-metal. So, if you want to debate whether it is a metal or not, you can say that it resembles a metal because it has a configuration of NS1 in the outermost shell, that is a valence shell. But if you want to argue that it is a non-metal, it never loses electrons and shares electrons and forms covalent bond. Now, what is catenation? We have already learned the definition. Please go back and learn it. Why do the number of organic compounds compete with the number of inorganic compounds? See, all organic compounds contain carbon. They are carbon containing compounds. Inorganic compounds are the compounds of all the other elements put together. But still the numbers are almost equal, if not more, at least equal. It is because of the catenation of carbon, where it forms long chains, branched chains, rings, and other structures which you will be learning in higher classes. Have a nice day and we'll meet in the next module. Thank you.